It'll be a review, if anything. All right. All right. Very challenging question. Oh, it's frozen. Sorry about that. All right. Go ahead and try to solve for this problem. I don't know if you'll figure it out. Oh, sorry. Yeah. If there's no more markers, then I have more markers. Show me every step, too. Be redundant.
So if we did it that way,
What's that?
should we do it? Or do you want us to do it
Oh,
the other way?
yeah. You can totally do that. You can divide both sides by two.
Okay.
I'm just kidding. Give me one.
Thank you for that trip,
Yeah, I haven't adjusted the grade yet. Yes. Okay. You know you got it already?
Thank you.
Okay, of course. Okay.
I was too focused on my
I do care if I get a bad grade, and if I don't get mine back up to an A soon. Oh my god, there's such a thing as retake.
All right. All right, guys. So if you guys got negative 18, you guys are on the right track. You guys are correct. Anybody have difficulty with that? Okay, just a nice little check-in, but also this leads us into what we're going to talk about today. We're going to be learning about proofs. Are you excited about proofs? No?
Sure, let's say you're excited.
Let's say we're excited, because we are excited, right?
Sure.
Okay.
I'll let you keep hope. Why not?
All right. One other thing, too. I gave you out handouts for a bunch of different properties. I guess I got to put it under a DocuCam so people at home can kind of see this, too. These are cheat sheets because these are all things you're going to have to use in what we call proofs to prove things. The first thing that we learned from 5-1 were these postulates. And then we learned about the midpoint theorem. So we set up a proof. We had to use this midpoint theorem. In the future, you're going to have to use a whole bunch of other properties. And I don't think it's quite fair for you just to have to memorize them all. Okay? So you can use these cheat sheets on your exam. Okay? This coming exam. So don't spend your time trying to memorize these properties. What I would really focus on, though, is trying to figure out how to use them. Okay? And how to work them on these proofs. If you don't completely know what's going to go on right now, in your mind, there should be a big blur about like, I'm not quite clear about what's happening, what he's saying out there, up there, up on the in the front. Okay, so keep these. Eventually, you're gonna have to make your own, right? Because towards the later chapters, I'm not gonna make cheat sheets for every section, but I decided to make them all right now for you guys. Okay, so hold on to this. So the first thing I want you guys to do is flip to the 5-2, this cheat sheet, and look through these properties of equality. Take about a minute or so just to look through them. And I must ask, have we seen any of these properties before? Oh, Marla, did you want to? We've done. Oh, you've seen this stuff in the 8th grade? Addition, subtraction properties, multiplication properties. Okay, so it's nothing new to you guys. Let's see how it's going to be used in the context of the algebraic curve. Yes, did you want to add something?
Are you sure it's 5.2?
Yes, I'm sure. Yes. She asked because there was a time where I spent 10 minutes up here fumbling which section we were on. Okay, well, what section were we on? I don't know. Okay. All right. So here's an example, or here is a subtopic. So please write this down. You should have 5.2 algebraic proofs. We're going to be justifying each step when solving an equation. Think about it. Did you solve an equation today so far when you stepped into this room? Okay, so you solved -5 times x plus 4 is equal to 70. What is the value that gives me that statement? To make that statement true, you found it to be x is equal to -18, right? But in proving things, you can't just solve for it. You kind of want to know why you could solve for these things. What properties let you say that x is actually equal to -18? Okay, you gotta kind of be a lawyer here, right? You went out and you threw a baseball in the glass. Great. Okay. What laws did you break? Okay. What laws were there in place? Okay. That's what we're kind of setting up now. Yes.
Are we answering your question?
What?
Like, do you want us to tell you?
Tell me what
Like how, like what we did, what properties we used. So.
Sure. Go ahead. Yeah. Do you have a
Yeah. Okay.
What properties did you use?
Depending on which one.
Uh-huh.
Depending on which method you use, you could either use the division property of equality,
Like you're
or
saying.
the multiplication property of equality.
Wait. How would you do the multiplication property of equality?
Well, if you look at the other examples on the board, they use the multiplication property. Well, actually, it would be the distributive property.
Okay, that's
By
correct.
Distributing -5, while my group used the division property of equality to get rid of -5.
What else did you use? Did you
We used-
hold on? Did Luciana use anything else? Any other property? Yeah, Sophia. Yeah. Where? Oh, it would be the subtraction property, right? Oh, but you added. Oh,
Yeah,
I see.
you can either use distributive property or division property of equality, or you can use addition property of equality or subtraction.
Okay, so we all kind of understand that we use a bunch of different properties of equality, right? So I'm just going to show you and model for you guys how to do it like in a nice formal way, right? I'm the guy that's telling you how to write the laws and how to obey the laws, okay? Or how to write it out for your judge to see, okay? So here's the first example that you might see. Prove if -5 times x plus 4 is equal to 70. Prove if this statement, if -5 times x plus 4 is equal to 70, then x would be equal to -18. So in this case, like I said, they're not asking you to exactly solve it. They've already told you what the answer should be. But what you need to do, the main crux of this, is to write justifications for each step. So this is a type of problems these are the type of problems that you will be seeing, okay? So how I set up my proofs is I need to make a table of various statements. Okay. I need to make a T table here, right? And then on one hand, I can make a bunch of different statements and moves. And then the other kind of column tells me the reasons or the theorems that justify why we can do these things, okay? So we're kind of going behind the scenes. What makes each of our steps work, right? I think most of us have already seen this. Does anybody know how to first start an argument or a proof? What's the first thing that we should bring up? Mark. Yeah, a given statement. What is given to us? What is a given statement? That was just given to us. Yes, by that.
-5. The first, like what -5 times x plus 4.
How did you know that was the given statement, by the way? Is there any words that kind of triggered this or no? Prove if, so if I say prove if this, that means that's pretty much given to me, okay? If this is happening, that's the given statement. So -5 times x plus 4 is equal to 70. Now, this doesn't need to be complicated. Like what? Who wrote in blue? Not blue. I'm sorry, purple. Right? Sometimes I argue that's pink. purple. Yes, Petunia. So what's the first thing that you did? Okay, so that's what we're going to write in the second step. I have distributed, or Petunia has distributed negative 5 to the x and the 4 on the inside. So that'd be negative 5 times x. Yes?
In the book, it's like it takes, if there's like a wrong thing after they, how Petunia did distributive property, then they solve it out, and then they say substitution.
Yes, so that's what I'm kind of.
Couldn't you just do distributive property plus substitution?
You could, but here, let me kind of hit on what you're talking about, because not everyone necessarily is following exactly what you're saying. Okay, because this is the first time they've been introduced to the content. Okay, so that's the distributive property of equality. So that should be from your chart of different properties of equality that you can do. Right? There we are. We see the distributive property right here. Okay. If you have A times B plus C, you can distribute the A to both the B and C on the inside, right? So what Fayad was saying was this. After you multiply negative 5 times x, what should you get if you multiply negative 5 times x? Oh, an epiphany, right? How about negative 5 times 4? So what the book likes to do, it likes to show every individual step, including actually writing out what you have cleanly after you've done some work. So
is that necessary?
It's
Or
not.
Can we put distributive and substitution? Yeah, that's what I was saying. Because that's what I did for homework.
That's perfectly fine. Yeah, you can do it however you like, okay? But some people, I like to do it as cleanly and as robustly as I can, comprehensively, okay? So this is what we call the substitution property, all right? All it is we're just substituting the values for negative 5 times x with what that equals to after we do the multiplication. That's literally negative 5x. And we're substituting negative 5 times 4 with the actual value that it comes out to, negative 20. That's why they call it the substitution property. So say if you're a person that's very detail-oriented, let's say like Katrina is very detail-oriented with her work. She shows every individual step, okay? The reasons why she could justify the in-between steps where she has to have it cleanly written out is the substitution property. That's what we typically use to do that, okay? Okay, what next? This is going to be an awesome exercise in how much algebra 1 you know, okay? What do you do next? Yes?
Add 20 to both sides.
Okay, so here, you would add 20 to both sides of the equality sign, okay? And as you can kind of see, the reason why the substitution property is there, I'm thinking also, I think their intent is sometimes it gets kind of jumbled up. Like if you don't have this in between step where you can clearly see what the answer was before you added 20. If you started adding 20 early on and so forth, some of the properties can kind of overlap. I don't know. Like I find that it gets kind of messy when you do each step one by one. Okay, let's say a person looking over your work and over like your actual argument kind of gets mixed up in wait, what is this? Or how did they get to this step? Are they skipping steps? When you do it in this way, every step listed, including this negative 5 minus 20 is equal to 70, and then they have a separate step where they rewrite that and then they add 20 to both sides, it makes it really clear what every step looks like along the way. It just makes your work a little bit more clean. You don't have to do that, okay? So this is the addition property, right? Technically, you're supposed to say of equality, but for your homework, you don't have to do that, okay? Just tell me addition property. I already know what you mean, okay? Following my format, what should be the next thing I write then? What's the next thing? Yeah, Fayad? Okay, and what is that going to look like, Fayad?
Minus 5x.
Uh-huh. Okay. That is the substitution property. Also, it's beneficial that I go through this with you like this because I don't want to give you one way to do it, and in the book you're looking at another way to do it. It looks kind of confusing. But I know some of you guys don't care either way. You guys can kind of figure out. Yeah, go ahead.
Is it the substitution property or just substitution?
Oh, was there? Let's see. have a look here. Substitution here. Okay, maybe it's on like another chart here. Okay, so for this, when we're dealing with like solving a problem like this, like solving just for like an x, we use the substitution property of equality. But I think in your book, they actually might at some points shorten it down to just saying substitution, where I think it's synonymous. Or is there a case where they're very different?
If the angles and if they're congruent, then you would use the substitution property if you're going to switch them out.
Oh,
Like substitution this way, it's like.
I got you. Yeah, and that's not necessarily of an equal, like, or a problem with an equality sign, right? So yeah, so I think it serves the same, almost a similar purpose, but that provides context. If you say property of equality, we automatically know you're talking about a problem like this, like an algebraic problem where you're solving for a variable. In the other context, there is no equal sign to worry about. So, but it still serves a similar purpose of substituting values. So you just say substitution when you're dealing with angles, and when you're dealing with an equal sign or a problem that involves equal sign, you say property of equality. For me, it serves almost a very similar purpose, so I don't mind if you use substitution in either case. Does that make sense? Okay. But thank you, though. Thank you for being so clear. Okay, what's the last step, guys? Here. Okay. I know you guys are all on the edge of your seat, but it is dividing it by -5. Okay. And then that would be the, brace yourselves. Yes. Kind of came out of left field for you guys, didn't it? Okay, the division property of equality. And then finally, well, what are we going to have for my statement? Yes, you're absolutely correct. So that is substitution property.
So basically another thing I like
Uh-huh.
this proof thing, you just write out your steps of how you solve it, you just give a reason how.
That's it. That's what proofs kind of are, actually. Yeah. You said there's more to this? There's more to life than just steps and justifications, right? Yeah, that's absolutely true. But this is just one facet of the life of math, okay? All right, that being said, you guys have already kind of done it, right? Now you're just adding reasons to it. Why don't you guys do the same exact thing for this? 2 times 5 minus 3a minus 4 times a plus 7 plus, no, I'm just kidding. Okay, solve for this. Okay, everybody please get out on the whiteboard. Okay, I'm going to turn on the lights. I'm going to open one of them. Huh? I want you to prove. Oh, you love this? It's so fun.
It's not fun.
Well,
Hard. It's making your brain work for no reason.
well, there will be points where you have problems that are very unique to proofs. Wait, what section are you in?
Mr. You can't see. Can you turn off the lights?
Okay. Oh, you want the lights off?
Yeah, you're the
I have one. We'll compromise. You really like the lights?
Yeah, it's like there's so much glare.
Oh, I got you.
I think it says 2.
All right, so copy down the problem.
We can't see it.
Indigo, can you move up the paper a little bit? Well, watch out. Don't trip, okay? You have to trip. Stand up. All right, very good. Thank you. Watch out, don't trip. This is not the action. Isn't that cool though? Indigo's kind of ushering in the Christmas fever. Oh, thank you. The more the merrier. The more the merrier. No, oh, we have to do it.
Yeah.
Oh wait, no, that's to do with different parts.
No, and then
Can you write Okay, they wrote really big too.
I always write really big.
I do it.
Everybody else writes so small.
You don't have to write them.
Literally, one division property.
We're not doing the weird stuff.
Yes. Oh, I see what you're saying. Yeah, there were a few problems.
Okay, I'll do
Yeah,
I'll do
do
that.
that. Yeah, exemplify what you're talking about. Yeah, simplify that. The function of either just
minus
Oh, I have no idea. I'm not talking about the test. I'm talking about the district test.
Yeah.
I was gonna ask if I could skip your class to go to it.
Well,
There's the morning session, but you have to be there in the first 15 minutes. Like it starts at 9.
oh really?
Yeah. So it's just like the it's a district
She is
afternoon
kind of. Go ahead. Continue. What?
one. No, you were talking.
I'm not really involved in you. Whoa. Is that a body language you're saying get out or friendly?
Test about
Now, what is the district test about?
Why do you have a seat? I'm not just gonna talk about it.
When should I come to take this agenda math test? Last week.
I'll be honest with you. When I gave you the directions, I didn't really know. I didn't read them, so I have no idea what you're supposed to do. I think you just take it under Sealy, schedule a time. Ah!
You act like your
My
test.
test.
Yeah, your test.
Actually, what you need to do is you need to go talk to Miss Healy. I'm just kidding. Yeah, on my website, there's like a bunch of times. So there's a bunch of times and days you can pick. You just need to go under the retake
Okay, we
tab. And you click on that.
Oh, wait, it's not 122.
It's the same. Retake or make it.
I really don't.
And then just email me a time of day. You don't have to take it. So today, you'd have to take it at 12:30. So to the end of the day, somewhere in between that. If not, you can take it. I won't be here tomorrow, so you can probably take it sometime this week.
Okay, that works so much better. I don't have to take like 5 different tests today.
That's not good. That's not a lot.
Make them all the tests. I'm gonna choose that today.
Yeah, just I don't want to have to wait though. I want to just go to
You have to, but I don't
Oh, but you're saying it's there. You're cognizant. Perfectly fine. Hey, I'm gonna give you guys about 20 more seconds, and then I'm gonna post up the answers so you guys can check it out. Then we're gonna go over something.
You start out really big and you color them, and then you put them in the oven and then you shrink down. I don't need to shrink. Come on.
Okay.
Oh,
I'm
yeah.
not. No, the funny is I was thinking about shrinking.
Oh, wow.
I didn't know what it was.
This is Arnold. I made him an art.
That's really cute.
I don't.
You are, or you made one?
I made them.
Oh, okay. They said I am a snowman. And then,
I guess I didn't know how to.
huh? You
I don't know the right phrases. I don't know.
for what? For what you mean?
No, it's just.
Oh, sorry. I'm sorry. I'm mixing myself in. I am quite the lost man. So. All right, go ahead and check your answers. This is what you guys should have gotten. About. I got it done in about 7 steps. I think you guys have shortened it down. You got 8. You got it in 7. 8 steps. Okay. Something. The more the merrier. That's not bad.
We didn't do all that substitution. We did it for one. Wish it was there.
Yes. Okay, I like it. I like your commitment. And just teeters off. Okay. All right, guys, we're gonna work on a long one, so brace yourselves. I know that's a sigh of relief, like, oh yes, we get to do more of these proofs, right? Okay. So, does anybody know what kind of math the district had before integrated math? Geometry. What else do we have? Algebra, all of it. Trigonometry. Okay, so we're finally reaching a point where we're integrating more geometry, and actually proofs are very much a geometry concept that's introduced mainly, and it's very unique to geometry. But the last problem kind of blended in algebra and geometry. This is a proof that is strictly in the realms of geometry, okay? But it's all kind of fused together in what's called integrated math. By the way, do not forget to take your mandated district test, okay?
Yeah,
I-
you can, but you have to email Miss Ely.
Yeah, it's kind of on up to Miss Ely how you guys do that. Yeah. Read the. I'll be honest with you guys. I gave you guys directions, but I myself didn't really read them. Okay, I'll be perfectly honest with you. Mr. Greenwood actually came up with it because all his students are having to take this too. Does anybody know why we're doing this district assessment?
Yes, to give the school money.
Math for money.
Yeah, I'm pretty sure about it. It's so the state can
Well,
gather an idea of how well our school is doing mathematically.
Well, what it
Why
really
are they
is.
just doing integrated too?
Well,
No,
what
they're
it
doing 9th grade too.
what it really is, guys.
They're
Hold on.
Okay. So they're just doing
Let-
the integrated. Wait, I mean,
Let me explain this to you. Let me explain this to you. I think you're jumping the gun. What is this? Okay, it's not proofs. Okay, all it is critical thinking problems to see not where you are, like where's Marla right now. Okay, where's Natalie in math? How far are you in math? It's not that kind of test. We just hired a person in his firm, okay, to come in and revamp our whole math curriculum. It's like a 10-year process. Let's say it's gonna be a long time. Okay. He wants to revamp it in a way where it's going to be more functional for today's society. Petunia even took it. Petunia, can you add like maybe 1 or 2 comments to what the test felt like as opposed to what we're learning in class?
Problem solving.
Way more problem solving, right?
It's more like competition math than what you learn in school.
Competition. Okay, well, I don't. It doesn't mean to be competitive, okay?
No,
But
but competition math is more like problem solving in comparison to school math.
is it like strictly proofs?
No.
Okay.
It's like real world.
It's real world math, right? Okay.
Yeah.
We're slowly kind of transitioning to real world math, okay, in a way that's kind of digestible. He needs, this guy in his company need to have a baseline for where we are, okay? We're spending a lot of money. How much money do you think we're kind of paying him in this company to help
A lot. A number.
Too much. Too much. Yeah, Indigo.
20,000?
That'd be really nice if we can get him for 20,000. We're talking, possibly up to millions.
Yeah, I was gonna say it has
So,
to be at least a million.
I hate to say it, but time is money. We got to use his time wisely. So he's doing us a favor by saying, hey, I need to know what I need to cut out and what I don't need to teach you guys, but also what I do need to kind of see, like I need to kind of, fix. okay? Or kind of gear you guys towards. Wouldn't make sense if he's like, I think everybody should learn division again. I think we all kind of master division, right? So we don't want to have him we don't want to spend millions of dollars paying him to just teach us stuff that we already know, okay? So he needs to know not where you guys are individually, but on average where the district is, okay? So don't over prepare. That doesn't send a good message. It's like, are you guys always like this? Are you guys always on fire in terms of your math skills? No, we just want to see the everyday math, okay? The everyday math. No, it's just unique to this year. And Miss Principal, Miss Brown just got the heads up. Like, wait, what? We only got 2 weeks to tell the kids. And Mr. Green and I were like, wait, what? We only got a week to tell the kids by the time we got the information. Okay, so don't worry about it. It's kind of last minute, but just take it. Yeah. Oh, don't say that. It differs for everybody, right? But how long was it? I think that's what we want to know. How long was it between you? What?
Yeah.
It was short?
It was like 15. Other people were like 30. So.
Okay, but it doesn't go beyond an hour, yeah?
Yeah, I know.
Right?
I really wanted to do it like in the morning.
Did you?
Yeah, but like I couldn't do it because he's supposed to come like in the beginning of like the test session.
Uh-huh.
And I have class.
Oh, I got you. Yeah, don't worry then. Just make it. I know.
Yeah,
So-
Mr. Reed.
Sorry, guys. I really want you guys to be here. So. Yes. Okay. Go ahead and write this down. Okay, so you guys should be able to visualize this in your head, okay? If angle ABC was congruent to angle CBD, and then angle CBD was also congruent to angle DBE, so easy, okay? Then x is equal to 6. Duh, right? Okay, I love that reaction. I'm just kidding, okay? You don't know what's going on. Huh? I love confusion. I love the state of confusion,
Why
okay?
is x equal to 6? So then the
Wait,
answer
so
is angle ABC is equal to angle DBE. Because of
Is it
the
just
other-
then x equals? Like what is it equal to?
Your hand is hiding. It's transitive property.
It's not.
Yeah, it is.
Okay. Wait, what?
It's transitive property.
Okay, cool. Well, yeah, because you have to.
Fayette,
What is x equal to?
Fayette, don't throw more confusion into the confusion,
No, but
okay?
it's right.
In the book.
It's right here.
Okay, yeah, but I haven't
No,
even.
but what
Okay,
is x equal to?
the thing is, I don't have a picture yet to provide any context.
Thank you.
Okay, so I was
that
intentionally
DBE?
making you guys confused.
It looks like F, but I think it's an E.
All right, guys, you know what?
I'm telling you, for Christmas we should get in those like a stencil. Yeah, but, like kindergarten like trainers like the A. If
Feel-
all these letters are congruent, that means X is. We just need to
Slightly-
get a few letters. Your A's and B's are pretty good.
Okay.
You're welcome.
It looks like an L. Your C looks like an L.
What looks like an L?
Yeah,
The
it
C.
looks like an L.
It does look like an L.
All right, guys. Anyways, okay. Let's prove that x will equal 6 when we only are given these little bits of information. Oh, one other thing that I did not include is angle ABC, what it's equal to. It is 6x plus 7. How infuriating would that be? Okay, if someone just said that. How big is the door frame going to be? Yeah, it's 6x plus 7. What? Someone's going down, okay? 8x minus 5, that's in degrees, okay? Both of these measures are in degrees, okay? But we need to find an x value in that. But hold on. What you got? Yes.
DBE is 8x minus 5?
Yes. So
Okay.
D to B to E. So in case you don't know how to read the angles, right? Usually the middle letter kind of goes into the middle of what your angle construction is going to be. So if the angle is constructed with A to B to C, B is going to be right there, kind of like the guy that connects the two line segments to make an angle. Okay. So angle A to B to C is congruent. All we know is it's congruent to this guy, CBD. We actually don't know if these two are equal to each other. Okay. So these and these are equal to each other, yet we don't have a value here. Uh-oh, that's scary. But we do know that CBD is equal to this. So I think you can kind of get the gears turning in your head. Wait a minute, if one guy is equal to the other. We're going to put formalism and steps into solving this problem. Okay? So again, we always start with a 2-column argument. Statements and reasons.
On the board?
Is it gonna be the last time we're gonna use the statements and reasons, or are we gonna do it next month?
This is just the beginning.
It never stops.
It never stops. It gets more fun and more fun and more fun. It becomes funny. Fun. Sorry. Not funny, but fun. Okay. All right. What things do we know so far that we know to be absolute so far that are given to us? Yes, Faya.
The thing that you said in the beginning, we can't see.
All right. Like what things?
Angle ABC is congruent to CBD and the other one.
This is too much to write.
Yeah, I just drew an arrow where it says.
What? Okay, on your exam, please don't do that, or else it's gonna be a million arrows. Like, okay, what is going on? Okay, just write it out for me on the context of the exam. Just do that for me, okay? I'll say this: there are 2 other things that are given to me through the picture. It's quite okay. Yes, Luciana.
Well, you know that ABC is equal to 6x plus 7 degrees. Well, like, and then DBE is 8x minus 5. And that's all given.
Okay, so one other thing to add. Oh, sorry. Okay, so one other thing to add here. One other thing to add is if you are talking about equality, okay, you do have to specify for at least angles that it's the measure of the angle, okay, the measure of this angle. Equality, again, is not the same as congruent. Let's say that me and Petunia, let's say, are we congruent in shape and size? No. But what could we be equal in? In weight, okay, what else? Or, in intellect, maybe? Some people might argue one person more than the other, right? It just depends on what you're measuring, right? So here, congruence talks about everything. We're identical in almost every way, but when we're talking about equality, it's some measure. Something is being measured to be equal to each other. We just don't know what, right? And the angles, maybe the angles aren't perfect alike, but we can at least say the angle measure, the measure between the 2 lines is equal. Okay? So you got to be really specific. That's why they say M here, but in the congruence, we don't have the M there. Yeah.
Can I do the next step?
Okay, go ahead.
Okay, so the next step is transitive property. Then it would be ABC is equal to DBE.
Hold on. One other thing too. In your book, I do have to specify in your book, it'll say this. Because these 2 are congruent to each other, should they be also equal to each other? Yeah, Sophia?
Yes, and it's the definition of congruent angles or whatever it was.
Yeah, you're absolutely right. So it's redundant, but it is in your book. If these angles are congruent to each other, guess what? Their measures are also equal to each other. Equal. We're talking about the number. We're not just talking about the shape. We're just talking about specifically the number values.
Then finish with the definition of congruency.
We're writing everything all over again.
Sort of. With hold on, wait. So what makes it awesome? Okay, you gotta be thorough. Okay. Yes, I'm very certain. Okay.
You're very short.
You need hearing aids. Yeah, I can't hear, guys. Okay, so if you're congruent, you're equal. That is literally what the definition of congruence is. Okay, the definition of congruence, or specifically congruent angles. You can do that for lines. If they're congruent, they're also equal to each other. You can do it for circles. They are congruent. They are also equal in measure to each other. Okay. So if you don't want to say congruent angles, you can just say the definition of just pure congruence. Okay. But in this case, you can be specific. Sophia is very specific, which I like. Okay. Fayad, go ahead.
Okay, then the step would be ABC is equal to DBE, which is transitive property, and then you can write therefore 6x plus 7.
Hold on, you're jumping the gun. Okay. Take it one step at a time here. Okay. So Fayad said if we're ultimately we want to set these guys equal to each other because we know that if we set 6x plus 7 equals 8x minus 5 is equal to each other, we can solve for the value of x, right?
But don't you first have to write A, B, C?
But what I'm saying, yeah, right here, what we're given is that these are not equal to each other, right? But Fayad, what angles are equal to each other that we know?
A, B, C, and D.
Okay, so ABC, well, no, we don't know that DBE is equal to each other yet, Fayad, right? So break it down first. ABC is equal to who? Do we know exactly?
Yeah. ABC.
Is equal and congruent to who?
CBD.
Only CBD. That's all we know so far. But also, what do we know about CBD? Who? So if ABC is equal to CBD and CBD is equal to DBE, what can you say about these two angles across from each other, ABC and DBE? They are also equal to each other, okay?
Couldn't you also do like the opposite angle thing? Like,
We haven't learned that yet. We don't know. We don't know that yet. Okay. Nope. Okay. You live in obscurity. You don't know that quite yet. Okay. So in case that confused you, just look up at your second step. ABC is equal to CBD. Sorry, that's not CBO, but CBD. CBD is also equal to DBE. Guess what? ABC looks as if it's equal to DBE. We call that actually before Faya, don't say anything. Okay. Hold it to yourself. Which one of these properties would you use to describe what just happened? Yeah, Ivan. Yeah, the transitive property. Because if A is equal to B and B is equal to C, then guess what? A is equal to B and C. Yes. The transitive property. Okay, Faya, now where can we go with this? Just say transitive property. We're going to stop saying equality, okay? But just say, at least give me transitive property.
Do we ever have to use those like dots that say like that means therefore or whatever?
Not anymore. That's an old class. I would consider that a more classical technique. Did you? Okay, all right, we'll do that then. Okay, so number 4, where do we go from here? Yes, Sophia. Oh, because we know that ABC is equal to 6x plus 7. The measure of ABC is equal to 6x. So we're substituting that value in, right? Okay, and then now what? DBE can be substituted with what, Sophia? 8x minus 5. And what would you say we just did to justify that statement? Yeah, you just say this is the substitution property. Okay, substitution property. Okay, how about you and your table go ahead and work on the last few steps for me. Solve the rest of this. Actually, go on the board. Yeah, go on the board. Go on the board. Don't write all of it. Just write me the last steps. The last 18 steps.
Oh, fun. You mean 50, right?
50, yes, 50. Sorry, Dr. Kuzich. I'm always wrong. I'm always off the ball. Lights on?
No.
This is the theme song for today. Horror. It's a very spooky day because of proofs. Proofs freak me out, Mr. Wee. And so it shall be.
Okay. What? Addition? You want to do yeah.
I can write it out if you want me to.
Well, I mean, it doesn't matter.
I don't think you have to
subtract
it here and then division.
I would put it over.
And yes, we have to do that. You can't even fit any okay, and then it's division. No, and division and then symmetric or reflexive. Wait, Mr. Wee.
Yes, Luciana.
Is this symmetric, or is it reflexive? Symmetric.
I believe it's just symmetric. Yeah.
Yeah.
Oh, wow, you are very detailed. You even went down to that last step. Okay, that works for me. That's fine.
Wait, don't have to do subtraction again. Here. Yeah, subtraction.
Let's see if you guys can beat the amount of steps I did it in. I did it in 15.
7. We did 8.
Okay, whatever, fine.
We did it in 7.
I was just kidding.
Do we have to write it back on our paper? I'm not doing that. I already wrote it. Ha.
If you, yeah, I would suggest you do, but if you don't need to, I mean, notes are completely up to you. You can take whatever notes you want.
For certain things I need notes and others like this I like the notes we take to put in our packet, yeah, like right before the test, I look at like form and
Do you have to be there for the first 15 minutes of the afternoon session?
It's right here, put out the fire.
All right, guys.
There we go.
Those are the rest of your steps. It's really the last two steps, 10 and 11. I mean, it's true. I know you guys take it for granted, okay? But for the first time that happened, it's like, if 6 equals x, I believe x is equal to 6. It was epiphany. It was an epiphany back then, okay? Don't take that for granted. Who knows, guys?
Amazing.
Yes, it was. Like, back then, it would be like, is it equal? Like, on both sides of the, I don't know, okay? So, when they found that out, they gave that a name, okay? It's called the symmetric property. I'm going to say now, after many centuries, okay, it is taken for granted. It does not, I explicitly said, you don't need to do that, okay? I understand if you leave it as 6 equals x, that's perfectly fine, okay? I will say this. I will know in my head, by the symmetric property, it would be x equals 6, but you don't use it. But it is extra knowledge. That is, should count for something. All right, but check your answer. That's the rest of the steps. I'm going to give you, I think, one more before we move on to 5-3.
Are we doing it on the board?
Yes, we are actually. Yes. Sorry about that. Okay. Easy. If angle A is congruent to angle B. Yes. What? Okay. Go ahead, Miss Gato. It was good to seeing you.
What? Yeah. No, it's good if it started over here and then I'll work.
Why did I feel like
Ah!
I bet
Sorry about that. Okay, this can be done in very, very few amount of steps. Here's the challenge. I'm not gonna draw it for you. You draw it.
Yeah. We have to draw it.
You gotta do the drawing. Yeah. What is angle A and angle B gonna look like? I don't know.
Oh.
What is equal 37? So they both equal 37?
Yeah, because it's
Well, yeah, so then.
Set up the argument, okay? Just set up the nice thing.
It will be very.
No, you have to draw a picture.
It'll be very.
You have to draw a picture? Or you draw the picture? And you did the picture one. I'll grab another pen and then measure
Just
angle.
180 degrees.
Oh, that's
I'm gonna share that with the rest. Wait a minute, but that's not 37 degrees at all. You just made it equal. Just fix it. Okay. Okay. All right. Only you can bend the
It's just really zoomed in, but not like really small point right at the angle where they come together.
You zoom in enough, it's 180 degrees. I guarantee it. I just don't have the equipment to show you.
Yeah, but that's like.
Given.
Right?
I like that, Ruby.
I'm probably right? Well, that's your substitution, right?
Given.
Mr.
transitive, right?
Isn't that technically all we have to like do?
Or,
And then you have to write.
substitution.
37.
No, because wait, no, and then
I was,
well, it's also
because is it? Do you get it? No.
But that's also a good
So angle A and measure angle are the same thing.
Well, I get that
But
it's
it's-
what is
so
that?
good enough.
Oh, it just means if this is
Yeah,
this
and
is
wait,
I'm just like getting
this,
after it.
then it's this. It's like
It's like
it was like
We did.
A equals B.
No, that's
Maybe less.
It's on the page. You get the
Angle.
Well, what's you guys figure? I did the steps. You got this. How many classes are there?
It's 10:18.
So then we have like 22 minutes. Not even
Like
22 minutes. 22.
Don't we get out at 10:40? No, we have like 15 minutes.
35.
35?
Yeah.
Oh, 17.
15 minutes. That'll be a good amount of time to do one more exam. All right. Actually, it was kind of interesting when I gave you guys the exercise to do different, or to draw it. Petunia actually has angles that are intersecting, two lines that make that angle. And that's a really kind of advanced drawing.
Oh, mine were totally 90-degree angles.
Just straight 90-degree angles, even though it explicitly says 37, but okay, that's fine.
37 degrees.
But
Yeah, this is parentheses. This is 37, not 90.
that's
You
the
look at it really hard and squint. It's 37.
Oh, it's an L.
okay. So this is what you guys should do. If you want to extend this out, you could have made this into about 5 steps. You didn't have to. Oh, you actually used the symmetric property. That's actually really good. Do you guys want to find something that I found kind of funny from observing some of you guys today?
You just have 2 steps.
What?
Okay, so in the same vein that you guys kind of did like 2 90-degree angles, even though it says explicitly it's 37 degrees, Dr. Hibbert, I looked over and he did this. We're done, Mr. Wee. Why is it that the 2 angles are equal to each other? What angles are they? They're both 180 degrees. So I looked at his paper. I'm like, what are you doing? He's like, I don't know, Mr. Wee, but I figured it out. I said, is that 37 degrees? So
I don't want that like a protractor and be like this.
so here, yeah. So here's what he did. I'll fix it, Mr. Wee. It's very simple. I'll just do this. I was like, you dope. Only Dr. Hibbert.
Correct.
Yeah, technically that is correct. Only
He's
Dr.
not
Hibbert.
wrong.
Only he can bend the rules to within the rules to.
That's why he's a doctor.
That's why he's a doctor. That'd be scary if medicine worked that way too. I don't know how that would look or if that would be ethical, but he's doing something right. Okay. Oh, dang it. Okay, hold on. Let me fix this before we move on. 37, 37, 37. Okay. It's quite funny. I was quite amusing. I was amused. Okay. All right, now we're going to move on to 5-3. So I know, Hassan, you were very interested in 5-3. Okay, so on the top of your heads, the cover sheet goes up to which section? 6-1 or 5-6?
5-6.
Okay, so
5- something. It's 5-6. I
so
know that for a fact.
I'm going to go probably over one example in 5-3.
You sure it's 5-6?
I don't know.
This is gonna happen every
We're going to take it
I'm
at 6.
gonna ask every single time.
Well, she is trying to save you time if you think about it. So, because
I don't want to write
We
down
lost-
and then spend 10 minutes
For some
figuring
reason,
out
yeah.
it's the wrong thing.
yeah, I somehow made that into a 50-minute process.
Does that say segment?
Yes, segment relationship. Proving segment relationships. And so I'm going to make a video on the rest of 5-3 and 5-4. And then next week is 5-5, 5-6. Okay? And then that should be enough.
Okie dokie.
Good? Got it?
Artichoke.
Artichokes. Okay. So using...
We killed their eyes.
Did it... Who said that? Okay.
What?
I-
What does that say?
Are we...
Using?
Are
Is
we
it using? Looks kind of like icing. If you look at it, what does
I
that
said
say?
it's using, okay?
It's using?
Yes, using. I forgot the N, okay? Using the segment addition postulate. And the example we're going to sort of launch into it, but let's back up a second after we write this down. Prove that if line segment CE, so if you have this is a line segment from 2 points, point to point, is congruent to FE, and ED is congruent to EG, then Luciana. Well, you know what, Luciana? I appreciate it because you do keep me on my toes for my writing. Okay, so this is CE. Not is equal to FE. This is EO. I'm just kidding. That's ED.
Equal, not it's technically congruent, not equal.
That's true. Okay, is congruent to EG, EG. Then CD is congruent to FG. Okay.
You're welcome.
Okay, I will draw this for you. There are two lines that are not necessarily I guess they are intersecting, but not at their midpoints or anything. Okay. This is C to D, F to G, and then the middle where they intersect is point E. This? Yes. Okay. Now I know most people are very tempted to just go by the picture and be like, oh, that looks about equal to this and this and this. Don't ever do that. Okay. Always assume that the person drawing it is not an accurate artist. Okay. Not an accurate drawer. Okay. So don't ever trust the images. Only go with the given information that's there. Okay. Given information that is explicitly written down. Okay. I'm just saying because what if I drew it in a way where CE looks just like ED? Do not trust that and say that CE is equal to ED. Okay. All right. So first things first, we need to talk about a few things from 5-3. So go to your handouts here. So it will feel redundant. And in the future, you're going to master these concepts to where we solve much more challenging problems. So bear with me for the first few problems in these few sections, okay? So in order for you to add, so could you say that on this line, if we broke this line into two different line segments, A, B, and B, C, if you add them together, what large line segment would it be equal to? If I add AB and BC? AC, okay? That is literally a segment addition postulate where you can literally add segments together. That justifies why you can do that, okay? Some other things are A to B is going to be, if you look at it, I know it looks kind of weird, but let's look at it like this. Like on a circle. That's a circle, I'm sorry. Not an egg, but a circle. Again, see? If I said, I would have to say, look at this circle, okay? You would have to just say that's a circle, no matter how bad the artist is. The artist says that's a circle, their intent is that's a circle, right? So always go with the given information. So just pretend that it's given that this is a circle, okay? Sometimes the question is, where does this line belong to? It belongs to both, if you think about it. It belongs to this half of the circle and this half of the circle. In this case, we could say that segment AB. Could you say it's congruent to like this segment? If we're talking about the top half's AB. Would you say that top half's AB is congruent to the bottom half's AB?
Yeah.
Yeah, right. So it's okay. Well, we call that the reflexive property. So you might be like, why is that important to say AB is equal to AB? You have context like that, where sometimes a line is shared between two different halves. So you do have to say, yeah, it is equal to each other. Hint, hint, that's going to be huge in the future. This looks like just something to scoff at. You will need this in the future, okay? Some other things, you're going to see if AB is equal to CD, CD is equal to EF, guess what? AB is going to be equal to who? F, no, EF. Oh, I get it. F, we get EF, okay? And then, yeah, so that's going to be the transitive property of congruence, okay? All right. And notice that's transitive property of congruence. So that is huge because we were used to saying the transitive property of what in the last?
Quality.
Equality. Okay. So it's not It's nothing to scoff at, okay? Just imagine, but there's like within a proof, guys, the Greeks, people in robes, okay, back then, okay, great mathematicians, there's even more proofs within a proof. You had to have like a dozen or so other proofs just to prove that this is true, okay? So the transitive property of congruence is slightly different from the transitive property of equality, okay? In that one is for equality, one is for congruence. Any questions? I'm sorry so far. Okay. I think Faya is just saying, get on with it. Just get on with it, Mr. Weeby. Okay. You guys are all asking for it? All right, fine. Sorry about that. Okay. Statements and reasons. Okay, so give me the givens, guys. I need given. What's given to me so far? What do I know so far? CE is congruent to FE. Okay, what else? ED is congruent to EG. Ultimately, what are we trying to prove, though? Okay, so we need to get to the point where we can say, so here's what we got. CE is congruent to, what is it, FE? Whoops, sorry. CE is congruent to FE. So these, even though they don't look like it, right? Don't trust my drawing. These are actually congruent to each other. ED is also congruent to EG. This is why this picture is so tricky. It doesn't look like that at all, but in fact, these guys are congruent, and these guys are also congruent to each other. Okay. All right. If I said CE is now equal to FE, and ED is now congruent to EG, did I? What's different about these two statements? There's no line, so there's no congruence. So this is equality. This goes from congruence to equality. What property allows me to do that? Saying that their shapes are just alike, that means their measures are also just alike. Anybody remember? Yeah? Oh, it sounds so trivial, but it's not. Okay? Took a lot of knowledge to do that. Definition of, I'll say congruence. How about we make this a little bit simpler? How about CE and ED? Can we add those two together? Yeah, because they're on the same line, right? So if we do CE plus ED is equal to, CE plus ED, what would that give me in total? CD. Okay. And what justifies that is a segment addition postulate. What else can we add together for segments? FE plus EG would give me what segment? FG. And that would be, again, the segment addition postulate. Let's see if we can find any relationships to each other right now. So let's see. Take a look back at these two. Let me see. What did I write here? FE and EG. Sorry about this, guys. Oh, FG. What do I have? Did I write something here? FG. Oh boy, hold on. FG, CD, FE plus EG is equal to FE plus EG. Oh, sorry guys, I'm stumbling here. Forgot what I was gonna say. FE plus EG is equal to CD. I think I'm missing something here. Hold on. ED is equal to EG. FE. Okay. Oh, yeah. Okay, so this part's going to be a little bit of a stretch, right? Let's write this whole thing again. That CE plus ED is equal to CD, right? But let's replace CE with something that it's equal to. Let's go back on step 2. What is CE also equal to? FE. So let's replace that with FE. And then what is ED? So CE plus ED equals CD. That's what we're writing, kind of rewriting here. What is ED equal to? EG. So that's what we call, we substituted in some values. So we'll just say that's the substitution. And we're not going to specify what substitution. Okay, Sophia. So we'll just say substitution for now. Okay. For lack of time right now, because I can't tell you which substitution property it is. Is it equality? Is it? I think it's equality, but we'll just say substitution for now. Okay. And then let me see. And then FE plus EG, we also knew was also equal to what? So imagine that you're rewriting this again, but in place of FE and EG, you're replacing it with what we knew in step 4. Does that make sense? So again, that again is substitution. Substitution. This one I'm a little uncomfortable with, but your book says from here, I could say because they're equal to each other, that CD. So in case you want to see the therefore sign, okay, if you want to know where to use it, you could use it right here. Therefore, CD is congruent to FG, which I don't necessarily think is correct, but this is the way that your book has it. It says that because they're equal to each other in measure, they're also congruent to each other. The definition of congruence. I think this would have been sufficient, and then their problem should have said, then prove that CD is equal to FG, but that's not how they have it written. They have it as the actual line segment is congruent to FG. Okay. Otherwise, I would say the first 6 steps are gold. Okay. All right, guys, that's it. Thank you guys very much for coming to class. Sorry if I held you up for a little bit longer. Oh, I think we're back. I'm 1 minute over. All right, 1 minute under. How dare I? Okay. All right, guys, you guys take care. Have a great day. I'm going to stop this video right now. Can someone turn the lights so that way we can kind of get out?